Hello, ladies and gentlemen. This will be our day 2 of energy sources. Today we'll look at solar energy, wind energy, hydropower, and biomass. This short presentation is just a quick intro, and you will go on and use the resources posted on our website to learn more about these 4 sources. So let's get started then with solar energy. Solar energy is the radiant energy that reaches Earth from the sun. There are 3 primary ways that solar energy is harvested. Um, the one that you'll focus on for your notes will be primarily this one, solar cells and solar electrics, sometimes called photovoltaic cells. Solar energy can also be collected through thermal energy or hot water transfer, or using something called passive solar design. So let's go ahead and talk about solar cells. So with solar panels, the light energy strikes the solar panel, and when that light energy or that photon comes through the surface of the solar panel, it excites the surface between the N-type silicon and the P-type silicon. N stands for negative, P stands for positive. And in the process, it excites that layer and produces an electron. So when an electron is released, then that electron can start flowing and electric current is produced. So simply by having sun hit this panel, electrons are released and electricity starts to flow. So that's pretty cool. Solar panels can be kind of expensive, however, and they're not very effective when the sun's not out. So there's definitely a disadvantage for you. But you'll find that whenever you do your research. One of the things about using solar panels as well is that they can be arranged in large-scale arrays, so they can be placed on the ground, and they can sit on tripods that follow the sun so that they're faced toward the sun all the time. Sometimes they can be small-scale panels like you see here on a house and just generate energy for one facility. Another kind of solar energy is solar thermal energy. And that is when the sun's energy is used to heat water that is inside of tubes. These tubes are concealed inside of something that looks kind of like a photovoltaic cell, but it's actually got water tubes that run through it. And then the hot water is piped down into the home and becomes a hot water source. The third type of solar energy is something called passive solar design. It's not really an energy source, it's just a way to use the solar energy that's available, striking a structure to maximize the heating that comes from the sun in the winter and minimize the heating in the summer. So passive solar design. Not an energy source, but a way that we can design buildings to take advantage of the availability of solar energy. So your primary focus on this will be on photovoltaic cells or solar energy that comes from solar cells. Okay, the next one is wind energy. Wind energy is due to the movement of air currents and the uneven heating of the earth primarily from the sun. So it's kind of logical to say that wind energy is partially due to the sun as well. That's kind of interesting. Wind energy is not new, as you can see from this picture. People have been harnessing wind energy for a very long time. Wind energy is dependent upon the topography of the area. This is a map of the United States and shows where wind currents are most intense. The darker color shows more intense and more reliable wind coverage. So this is a map that shows the way pressure affects wind because this is a low pressure center, so this is a weather low pressure map, and these marks over here indicates wind speed. So if you notice right in here, these are little flags that have lots of little marks on them, little dashes on them. So that corresponds with this and indicates that there's a wind speed of 44 to 49 miles per hour in this area. However, up in here, the wind speed is relatively calm. it's 1 to 2 miles an hour. So it's not completely calm. This would be a place where the wind is completely calm because it corresponds with this symbol right here. So this map can give you information about current wind speed and direction. So wind is variable. It depends upon current weather conditions. Another thing that wind energy can depend upon is that local bodies of water and the topography of the land. So there's usually a prevailing wind off of oceans, and that wind will often then move up the side of mountains because there's usually some higher structure, some kind of mountain range relatively near coastlines, and that produces some changes in wind patterns. So lots of things to consider when considering how to manage and maximize the energy available from wind as a source. Technology also greatly influences the viability of wind energy. This picture shows you an old-fashioned windmill, and those were used, centuries ago and used effectively. But now our designs are much more sleek and will spin at very, very low wind speeds. So technology has done a great deal to advance the viability of wind as an energy source. Okay, the next one we're going to look at today is hydropower. So hydropower energy comes from moving water. So classically, it's from a dam like this, where there's water dammed up behind a structure, and then the water flows through the dam. Here's an example of how the water is flowing through this dam, and this graphic shows how the energy gets harnessed. This is a good general description of how all power plants work, in that there has to be some energy source that causes a turbine to spin. So this is a generator right here. This thing in yellow is a generator attached to the turbine. So the turbine is spinning. The generator is attached to something called a transformer, and through that process, using some magnets and some electric fields, that produces an electric current. So what starts out as water running through a pipe turns into an electric current. Some of the other ways that turbines can spin can be from steam. So lots and lots of power plants ultimately change the energy source to heat in order to turn the turbine. But hydropower doesn't require that intermediate step of generating heat. Okay, the next way that hydropower can be harnessed is through something called a running river plant. This is kind of a classic example of an old-fashioned mill. The water would have been coming down a stream that is kind of in the foreground that you can't see. It would have been diverted through this chase, and then it would make the water wheel turn and then grind grain inside of this building. So this is an example of an early running river hydropower plant. Here's an example of a running river hydropower plant that's a modern day version. So there's a dam-like structure here, however, it doesn't increase the water level. It just harnesses the water on one side. Then the other side of the river can continue to run freely, and water runs through part of this and spins turbines, and much like we saw in the last graphic. So a running river hydro plant. These are used in the Pacific Northwest in the United States. That's where you primarily find them. But you'll find some, if you'd like to do research further on that, you'll find some applications of running river hydro plants. Okay, one of the really important things to notice about hydropower is that hydropower energies that you've seen so far use the water cycle to move the water around. So the water evaporates over oceans, moves across land. It rains, in a higher elevation. Then the water collects behind a dam, flows downhill, yada, yada, yada. You know how the whole thing works. So it's kind of interesting the way hydroelectric power plants are related to the water cycle. And it should come as no surprise to you that, gee, the sun is a really important part of the water cycle. So the hydro cycle is somewhat related to the energy from the sun as well. Okay, the last hydropower example that we'll look at is hydropower from ocean currents. Clearly the ocean has high and low tides. There are several designs for hydropower generation or hydropower capture from ocean currents. This is just one example of how high tide is captured on one side, and then the water will flow through in high pressure to the side where it's lower. Um, but that's a kind of a growing application in some areas to use tidal movements. Um, Notice that for hydropower from tidal movements, um, the source is actually gravitational potential energy, because it's the moon and the sun that pull on the oceans and get them to bulge, causing high and low tides. So um, the the form of energy is actually gravitational potential energy. So that's kind of interesting. Okay, the last one we'll talk about today is biomass. Um, Biomass is anything that used to be alive that can be burned. So anything in this picture, such as pulp, wood products, cotton, waste from things like cardboard plants, those could all be fibers that could be burned. Consumer waste that comes from natural processes, natural materials. Um, Crops and animals. Sadly, yes, you can burn an animal. Um, we won't linger on that. Anyway, um, so biomass is anything that used to be alive that can be burned. So it's a carbon-based life form that can be burned to produce electricity. And in much the same way I described before, it burns, generates heat, turns a turbine in a power plant, and generates electricity. And it should come as no surprise to you that since biomass is based on formerly living things, all living things on our planet, at least, um, are some way related to the sun, because the sun provides the photosynthesis required for primary producers that all other life forms then develop from, they eat or consume. So that's kind of interesting. It's another tie-in back to how biomass is kind of another kind of solar energy. Interesting. Um, okay, sorry, that's a repeat. So here are the energy sources then: solar, wind, hydropower, and biomass for today. Go back to the website and use the links there to find some more details about the advantages and disadvantages of each of these types of energy sources. Do a good job.